Good morning, everyone. Welcome back. So today we will keep on working on the Black-Scholes equation. In particular, how can we reduce it to the separable PDE? Okay. So recall in the last video, we say that V is a function of two functions times together, f and g, and f is a function of a and b, and g is also a function of a and b. And also, regarding a and b, a is a function of s and b is a function of t. Now, our next goal is we're going to replace on the partial derivative, you see? So what I mean is we're going to replace on the partial v over partial t here, partial v over partial s and partial v over partial s as a function of f, g, a, and b. Okay, so let's go ahead and do that. So let me go ahead and zoom in first. So first we say, we're gonna say we have v equal f times g, right? So if you recall the partial derivative rules, like if you want to write a partial derivative of a function, you write something like this. Yeah. So if you recall, okay, dy will be equal to dy over dA times dA plus dy over dB times dB. Okay, this is one of the way you can write partial derivative. And if, let's say, you have another variable t, dt, so if you divide one side by dt, dy over dt, it will be dy over dA times dA over dt plus dy over dB times dB over dt. Okay, so now we can use this logic in our equation. Okay, namely, v equal f times g. Okay, so if you use the products rule, you differentiate both sides with respect to t. So you get partial v over partial t equal partial f over partial t times g plus partial g over partial t times f. Okay, this is basically, I'm saying is u v prime equal u prime v plus v prime u. Okay, and this is the product rule. Okay, so what can we do next? That is our partial v over partial t. Okay, simple as that. Now, because remember we need to calculate partial v over partial s and the second derivative as well. So let's go ahead and proceed to partial v over partial s and see what we got. Okay, so partial v over partial s. So if you use the same logic, you will get partial f over partial s times g plus partial g over partial s times f. Okay, this is basically the products rule. Okay, as you differentiate with respect to s. Okay, cool. Now, what is the second derivative of this? This is where it gets interesting. Okay, so let me go ahead and highlight this. This is what we're interested in. So, the second derivative is the derivative of the first derivative. Okay, so you can take the derivative of the first derivative. So you take the partial with respect to s of partial v over partial s, right? And you already have partial v over partial s, so let's go ahead and block it in. Partial f over partial s times g plus partial g over partial s times f. Okay, and if you take the derivative of this, let's do it step by step. So it will be equal to partial with respect to s of partial f partial s times g. Yeah, let me use this bracket over here, it's more convenient. And then you add partial derivative with respect to s of partial g partial s times f. And if you apply the products rule for both of the term, you get this one is just g times second derivative with respect to s, and this one is just plus the first derivative, the first partial derivative times the partial derivative of g with respect to s. Okay, similarly here you get partial g partial s times partial f or partial s, and then you get f times partial square g or partial square s. Okay, so basically this term right here is this term. This term right here is this term. Okay, using the chain rule. Okay, so let me go ahead and simplify it. So g times partial f or partial s squared, and notice you can regroup this two term right here. You can regroup them, and so you get 2 times partial f with respect to s times partial g with respect to s plus f times partial square of g with respect to s. Okay, so you see it's this kind of patterns here. So this is kinda like a plus b squared, right? So you notice a plus b squared is a squared plus 2ab plus b squared. So it's kind of similar to that, but if you interested in this, let me point out here. If you interest, two things you're gonna do. The first thing you're gonna do is you try to compute this one, but like try to compute the third derivative of it, okay, and see if you can identify any pattern. And then you go to Google or Wikipedia to look up general Leibniz rule. Okay, and let me go ahead and Google it right now to make sure that's the right one for y'all. Is general Leibniz rule. Let me spell correct. Leibniz. Yeah, they will discuss more about this. There's actually this rule that you can differentiate it. And let me actually write the equation down if you're interested. So it's if you take the derivative with n time of a product, you get it's like a binomial sum. So k equals 0 to n and k n minus k the derivative time n minus k derivative of f and k derivative of g times. Okay, you can look it up more. For the sake of the length of the video, I wouldn't dive deep into this now, but this is a good start. Okay, so we got the second derivative of the both, right? So you see now we have f, g, and s. Okay, f, g has appeared. So let me make a conclusion. So here, notice f and g has appeared. Okay, what about a and b, right? So what about a and b? Okay, let's make a and b appear too, because remember our goal is to make FGAB appear. We write VST, we convert from the VST language originally to FGAB language, right? So let's go ahead and use the same rule. We can make it appear. So as I mentioned above, so let's say we have f is a function of a and b, right? This is how I write it. So f arrow FAB means f is a function of a and b. Okay, so you can write the differential. The f is f over phi a times dA plus phi f over phi b times dB. This is very important thermodynamic. Very important mathematical tool in thermodynamics. Okay, very important. Okay, so you use the same logic we have. Let's go ahead and evaluate each of them. Let me check a look at my note. Oh, okay. So you have this differential, right? You can divide both sides by dt. Okay, so let's see what we have. So partial f with respect to t equal to f with respect to a times dA over dt plus partial f b times dB over dt. Okay, this is where you notice something interesting. So you recall that a is a function of s, b is a function of t. Okay, as bt. Okay, so let's write it smallly here, as bt. So if a is only a function of s, then a is not a function of t. So dA over dt is 0. So you can cancel this term out because dA over dt equals 0. So what you got left is partial f over partial b times dB over dt. Okay, we're just gonna go ahead and calculate on this term right here, and then we'll, later you see how we use it. It might seem a lot at first, but bear with me. Okay. Similarly, partial chi with partial respect to t, you get what? You get partial chi with respect to a times dA over dt plus partial t with respect to b times dB over dt. B is a function of t, b is not a function of a. A is not a function of t, so dA over dt is 0. So this one you can say it cancel out because dA equal over dt is 0. Okay, so if you simplify it, you get partial chi over partial b times dB over dt. Okay, so let's do the same thing for s. So let me do it like this so it's more organized. Partial f with respect to s. So what is that? It's going to be partial f with respect to a times dA over ds plus partial f with respect to b times dB over ds. Recall as bt. Okay, so b is not a function of s. Only a is a function of s. So dB over ds is 0. So you can cancel this out. So because dB over ds equals 0. So you get partial f over partial a times dA over ds. Okay, next one, let's go ahead and move on to partial chi over partial s. Okay, you do the same logic. Okay, so partial chi with respect to a times dA over ds plus partial chi with respect to b times dB over ds. Okay, ASBT, a is a function of s, so dA over ds is a non-zero. B is not a function of s, b is a function of t, so dB over ds is 0. So you can say this one cancel out because dB over ds equals 0. So you simplify, you get partial chi respect to a times dA over ds. Okay, then we have on the term. Oh yeah, we need to calculate 2 more terms. Okay, you bear with me. So the next term is we need to find a second derivative of f with respect to s, the second partial derivative. Okay, let's do it slowly so that we doesn't make any mistake here. So this one is just the partial derivative of the first derivative. So it's the partial with respect to s of partial f over partial s. Partial f over partial s you already have. It's up here, so I can copy paste that. So it's just partial f partial a times dA over ds, right? It's from here. Let me make a... Okay. So yeah, let's do the same rules. Let's expand it. So here you will get partial with respect to s of partial f partial a times dA over ds plus partial f over partial a times partial with respect to s of dA over ds. So but basically that's just the products rule I'm implying. Okay, so here notice something interesting. Let me check my. Oh, okay. This is some. I'll do some transformation here. It's kind of look kind of weird first, but just bear with me, okay? So. Did I do something wrong? Let me check. It's kind of look weird here. dA over ds times partial a. Oh, okay. This term right here. Notice how I'll do the transformation. So this I will transform to taking the partial of a first, of partial f with respect to a. Okay, let me make the highlight for y'all. Okay, you with me? And then times dA over ds. Okay, so all this term, yeah, let me go ahead and do this. All this term right here become this one. Okay, so basically I'm saying, yeah, let me copy everything down. So this is just partial f with respect to a time the second derivative of dA with respect to s, right? So basically this one, that's what I'm saying. This is what I'm saying. I'm saying partial u over partial s, just partial u over partial a times dA over ds. Okay, because u is just, we assume that u is just a function of a for now. Okay, and you know dB over ds is not 0, so we cannot write a partial derivative for that. Right, let me see. Yeah, so ASBT, remember ASBT. So you cannot write partial u with respect to b times dB over ds. No. Okay, you cannot. This is 0. Okay, because dB over ds is 0. So just this term is fine. Okay, so that's basically what I'm trying to say. And then if you simplify this, you get partial square f with respect to a, the second derivative of f with respect to a times dA over ds. All the square, not the second derivative. Okay, be careful. This is dA over ds, and then you square, not the second derivative. Okay, so and then you plus partial f with respect to a times square over ds square. This term right here, the one I circle in red, is the second derivative. The one I put it in the rectangle is not a second derivative. It's just the derivative, and then you square it. Okay. So that is for partial f squared with respect to s squared, partial f, second partial derivative of f with respect to s. Okay. So let's go ahead and calculate our last term. Follow the same logic. So partial square g. Okay. So you can say this is just a partial with respect to s, partial g with respect to s, right? And then you just, this is going to be equal to partial with respect to s of, did I have that term? Yeah, here we go. So we go ahead and do this. Okay, makes sense. So yeah, so it's going to be GA DAS. So partial G over partial A times dA over ds. Okay, if you take that partial, you will get, first you take the partial with respect to a, or partial G partial A times dA over ds, and then you take the partial with respect to s of the second term, dA over ds. This is basically just the chain rule. You see what I'm saying? Sorry, this is basically the products rule. Okay, and this one I rearranged the same way I did for second partial derivative with respect to s of f. So I just introduce a in, and then times dA over ds. Okay, times dA over ds plus partial t respect to a of, this is just the second derivative of a with respect to s. Okay, so if I simplify this, I'll get partial square of t with respect to a times dA over ds square plus partial t over partial a times a square over ds square. Okay, let me check my note. Okay, it seems well. Okay, let me go ahead and bracket all of these so that we can use it later. Check my notes, make sure everything's correct. Okay, so to recap, what we just did is we find all the necessary partial derivative. We say if v is a function, is f times g, and we find all the necessary partial derivative. So later on we can substitute in our equation. Okay, we do it step by step. Okay, and also notice that f and g is a function of a and b. So I solve on the necessary partial derivative of it. Partial f with respect to t, partial f with respect to s, g with respect to s, and second derivative of f and g with respect to s. Okay, we use some partial derivative rule, some products rule to conquer the problems. Okay, so in the next video I will discuss with you guys how to substitute them back in, and then how can we solve the equation. Okay, so thank you everyone, and I'll see you in the next video.